Hi there, thanks for tuning in to this CNCF webinar. My name is Thorsten Hans and I work as a cloud advocate with Fermion. In today's webinar, we will explore how we can compose applications from multiple WebAssembly components written in different languages. We'll look at two demos in which we'll take a component written in one language and combine it together with a component written in another language and then run the entire application. So without further ado, let's have a look at some slides to ensure everybody's on the same page. The WebAssembly component model is an extension to core WebAssembly, streamlining and simplifying the way to compose multiple components together, no matter which language was used to implement one or the other. If you think about composing systems from multiple components written in different languages, you may immediately stumble upon like one language is laying complex structures in memory in a certain way, while a different programming languages use another way to structure its memory. It's the WebAssembly component model that provides a canonical ABI as a unified communication layer between those language boundaries, right? So that we can seamlessly consume a structure implemented in a Rust component from within, let's say, a Python component, without us having to translate the memory layout from Rust into how structures are laid out in Python in that example. To design and describe the API of a WebAssembly component, we use WebAssembly interface types or short WIT files. Okay, let's have a look at a practical example of where the WebAssembly component model could streamline your developer experience when building real-world applications. Imagine you're asked to implement a CRUD API, and you're confident in doing that with TypeScript, right? So you start your TypeScript project, you lay out the API, and while working on the TypeScript API, you start thinking, hey, it would be super smart if I could compress every response payload before sending it back to the callee. However, you've never used a compression algorithm or implemented one, but your colleague did. And they created a super simple API for compressing different kinds of data structures, right? So they can create a WebAssembly component distributed through a registry, and you can integrate it in your TypeScript API and seamlessly call the compression functionality they provide to compress all your data before sending them back to the callee. Okay, let's dive deeper into component composition. First, we will have a look at manual component composition using latest and greatest tools provided by the Bytecode Alliance and the WebAssembly community. So we will use WASM tools and WAG to take components written in different languages and combine them together. We'll then run that final component using WASM time. On top of tooling provided by the Bytecode Alliance and the WebAssembly community, we will also use language-specific tooling like Cargo Component in the case of Rust or JCO in the case of JavaScript and or TypeScript. Okay, let's jump right into the terminal. So in this folder, we have a component subfolder with two implementations of a sorting algorithm, a bubble sort implemented in JavaScript, and we have a merge sort implemented in Rust. Let's explore the WIT file of the merge sorter, and by the way, the WIT file for the bubble sort is the same. So as you can see, we export sorting capability. Next, let's create a new socket component using cargo component new. Let's go into that directory, create the WIT folder, and now we use WASM tools component WIT to take the existing WIT world of the merge sorter, invert it, and write it into our local WIT folder, and again call the file world.wit. Let's have a look. And we see it right now, we import the sorting capability. Cool. Next is doing a cargo component build to ensure bindings are generated for us. Let's open up the app in the editor. Let's go into the main.rs file. Let's bring in the generated bindings module. And let's use the sorting capability. So we create a vector of numbers in a random order. So the sorter is responsible for bringing them into the right order. Well, let's say we expect a sorted array. And as you can see, we can pick the sort function and get the import generated, provide a reference to our numbers array, and finally print the sorted array to standard out. Okay, let's close the editor and let's invoke a build, cargo component build. So now we have built the socket component. However, we have to whack them together. So we use the whack CLI, and first we point to the plug component, so the component providing the capability, the merge sorter in our case. We choose the path to the WASM file, followed by the path to our socket component. And that's in the local target folder again, wasm32 wasm p1 debug and the wasm file. And we tell it how it should call the composed application that's plugged.wasm. Let's use wasm time to run our app. And as we can see, we get back a sorted array of numbers. Next, let's use the bubble sorter implemented using JavaScript as a plug. Again, use our live demo.wasm as the socket component, and let's store that in plugged2.wasm. Okay, again, wasm time, run, but this time invoking plugged2.wasm, and we end up with a sorted array using the other component. Awesome. So we just composed together our first application consisting of multiple components written in different languages. To do so, we had to execute a couple of commands in a predefined order to whack together or to compose together the final application. In that particular workflow, the WIT management is some sort of manual, and we have to explicitly use WASM tools to invert the WIT interface of that functional component in order to make it work with our socket component. Obviously, we have to use language-specific tooling depending on the language we choose for implementing our socket component. So these are things that you have to keep in mind when doing manual composition using WASM tools and WAG. Alright, so let's have a look at an alternative approach on how you can compose applications that consist of multiple WebAssembly components. And to do so, we will use Spin. Spin is a CNCF sandbox project, and it's the developer tool for building and running WebAssembly applications, no matter which language you choose. Right? Spin gives you a language agnostic development workflow that is super efficient, yet super easy to understand and adopt. You can learn more about Spin on Spin's GitHub organization and on the documentation that is linked from there. On top of Spin, we will use the Spin Depths plugin, a plugin we created to extend Spin's core capabilities and streamline the process of component composition. So the plugin takes care about all the language-specific commands. The plugin takes care about automatic binding generation, leaving a simple spin depths add command to us as developers. And from that point in time, when you execute that command, you can simply move on and consume the APIs provided by your WebAssembly component in your Spin app with no additional manual step required. Again, let's jump into a demo and let's explore how component composition looks like when we're using Spin and the Spin Depths plugin. Back in our terminal, let's move one level up. So this is again where the components directory resists. And this time let's use spin new to create a new spin app using the HTTP/TS, the TypeScript template. And let's stick with the default values. Let's move into the application directory. So this is where spin.toml and all our TypeScript related files resist. And let's do a spin build for now, which will download all the dependencies and then build the application. So within a matter of seconds, we got our app compiled down to WebAssembly and we could move on and add the actual dependency. So this is a spin depths add and followed by the path to the component we are interested in using. In this case, let's use the merge sorter. So we point to the WASM file, hit enter, and then we got a wizard guiding us through configuring how and where we want to add that dependency. Next, we have to add the newly added dependency to our top level project using npm install. And by the way, this is a step that we will automate for you in one of the upcoming builds of the Spin Depths plugin. And with that, let's open up our editor over here. Let's find the index.ts, and for sake of demonstration, let me quickly do some housekeeping over there. We want to invoke our sorter for every invocation of our spin app. So let's say const sorted equals to sort, and as you can see, I can immediately pick and I get the recommendation, hey, this comes from the sorting package in version 0.010. So I can sort, and this takes an int array that I can fill by using the from method, and I can simply provide a couple of numbers over here, and I can use console.log to print sorted again to standard out. Sort, oh, did a mistake over here. All right, so let's close the editor again, and let's do a spin up -- build. So this starts the app, however it compiles if there are outstanding changes. Okay, the app is right now running on port 3000. Let's fire up a new terminal and let's simply send a get request to localhost 3000. Let's move back to the first terminal instance, and as we can see down here, we got the sorted representation of our int array back. All right, this was awesome, right? We just executed that spin depths add command to bring in the existing capabilities from our sorting component into our application. But let's be honest, let's do some real talk. What works and what doesn't? So as of today, we support Rust, TypeScript and JavaScript as socket languages, right? For those components that consume capabilities from another component. For the plug components, so that components that provide functionality, we support every language that could produce a WebAssembly component. However, to be fully transparent, this Spin Depths plugin is currently still in experimental stage. Okay, let's also explore the roadmap for the Spin Depths plugin. Obviously, we want to add support for additional programming languages when building socket components. We want to graduate out of the experimental state, and we want to take the capabilities from the Spin Depths plugin and bring them into mainline Spin so that everyone could use that great experience without having to install a plugin explicitly. All right, let's do a quick recap on what we just saw. First, we started off with manual component composition. We used latest and greatest tools provided by the Bytecode Alliance and the WebAssembly community, such as WASM tools and WAG, to combine two WebAssembly components together. But we did not stop there. We also took Spin and its experimental spin depth plugin to show a way smoother and more elegant way of achieving exactly the same. So with that, I hope you have a sense of how you can compose applications from multiple WebAssembly components using either the manual approach or the new way of doing that by leveraging Spin and the Spin Depth plugin. With that, thanks for tuning in and see you next time.